Greetings everyone, welcome to the second part of the video for section 5.3, continuing on with our study of the relationships between circles, angles, and points on circles. And yeah, let's jump right into it. Now, if you've talked ever to anyone who has taken a trig class before, they'll probably tell you that their favorite part was identities. And when I say the word favorite, what I mean is the part that they actually hated the most. But we're going to have fun with it in this class, so let's get into our first set of identities here, something called the Pythagorean identity. And before we get into what that identity is, I'm first going to draw another unit circle here. So those are my coordinate axes. Here's my circle. Recall that for the unit circle, what that means is the center of the circle there is the point 0, 0. And then the length of the radius is going to be 1. Okay? So let's look at what the equation of that circle would be if we're going to write it out. And so recall that we learned in our first section that the general form for the equation of a circle is x minus h squared plus y minus k squared equals r squared. And recall that h and k, those values come from the coordinates of the center of the circle, so in this case they'll be 0 and 0. And then we also know the value for r here is 1, so if we plug that information in, we'll have x minus 0 squared plus y minus 0 squared equals 1 squared. We know the 1 squared will give us 1. If you think about these here, x minus 0, well, that will just be x. So we'd have x squared, which will just become x squared. Plus, similar thing with y minus 0, so that'll be y. And then squared will give us y squared. So we see then that the equation of the unit circle is given by x squared plus y squared equals 1. Now, another thing about the unit circle, if we think at a particular angle theta, we saw in our previous video that the cosine of that angle is equal to x over r, and the sine is equal to y over r, where x and y are the points where the radius meets the circle when it rotates around an angle of theta. But because this is the unit circle, we know that in this specific case, the value for r here is 1. So we know that for specifically the unit circle, these ratios are x over 1 and y over 1, which are just going to become x and y. So what we see then is that on the unit circle, the value of x is equal to the cosine of a particular angle, and the value y is equal to the sine of a particular angle. So what we can do then is take and plug that information in to our equation over here. So instead of x squared, because we see that x is equal to cosine of theta squared, or excuse me, cosine of theta, I'll write this as cosine of theta squared plus, and then instead of y squared, I'll just write sine of theta squared equals 1. And then we've pretty much got the identity now. But we're going to rewrite it again. So here when we have something like cosine of theta squared, that notation can be a little strange because it may not be clear. Is the squared just for the theta or is it for the whole cosine? What does that mean? So the way we write that to try to simplify it is as cosine squared of theta plus, and then we do the same thing for the sine here. So this will be sine squared theta equals 1. And there we have our Pythagorean identity. Now sometimes you'll see it written in the other order, so it'll be sine squared theta plus cosine squared theta equals 1. but that means the same thing. So use whichever one makes the most sense to you. All right. So now let's use this identity on a problem. So, we talked about in the last video finding the sine or cosine of an angle using points on the circle and the radius. We can also use the Pythagorean identity. So notice here, we're asked to find the sine of some angle alpha, which we don't actually know what that angle is, given, however, that the cosine of that angle is equal to 5/8. So our Pythagorean identity can be super helpful here, because what the Pythagorean identity tells us is sine squared of alpha plus cosine squared of alpha. And so notice here I'm using alphas instead of thetas, but the identity will still work. We're told that that equals 1, right? That's our Pythagorean identity. We know what the value for cosine is. It's 5/8. So we can go ahead and substitute that in. So we have sine squared of alpha. And I want you to notice when I plug this in, okay, that 5/8 is not going to go in for alpha. So I'm not going to write cosine of 5/8. Okay, that's not correct here, because that's not the value for alpha. I'm also not going to write cosine of alpha times 5/8. Okay, that's not what this means either. Again, we're told that the cosine equals 5/8. So the 5/8 there is going to take the place of the cosine value. So this will become 5/8 now squared instead of cosine squared. Okay? So the 5/8 took the place of the cosine, and it's squared because the cosine was being squared. All right, now we can just solve for the sine value. So we'll have sine squared alpha plus, if we square 5/8, we can, if we have 5/8 squared, that means we can square both the top and the bottom, which will give us 25/64 equals 1. Subtract 25/64 from both sides. Okay. And when we do that, so we'll have now sine squared of alpha. We do 1 minus 25/64. We can do that by getting common denominators. So make the 1 a 1/1. Common denominator be 64. So 64/64 minus 25/64. Subtracting fractions, we just subtract the tops. So it'll be 59. I think we get 39/64. Is that right? 44/64. Yep. Okay. And then we're still trying to solve for sine, not sine squared. So that means we have to undo the squared here. And if you recall, the way that we do that is we take the square root of this side, take the square root of the right-hand side. And recall, when you're solving and you take a square root, you always get two answers. So we show plus or minus. And on the left-hand side, the squared and the square root will cancel out. So we have sine of alpha equals plus or minus. And then recall, when we take the square root of a fraction, we can do it in two parts. So we can do the square root of the top, so square root of 39, over the square root of the bottom, so square root of 64. So become plus or minus, and then that'll just be square root of 39/8. The square root of 39, we can't simplify anymore, and the square root of 64 is 8. So we have sine of alpha equals plus or minus square root of 39/8. Okay? Good? All right, we have one more thing we have to think about, though. This plus or minus. And the reason for that is when we have a specific angle alpha, okay, well, we can't have the sine of that angle be both either a plus or a minus. It has to be one or the other. So the next question is, how do we determine which one to use here? And the answer? We'll find out in a later video. Thanks for watching.